All right, so today we're going to talk about solubility. Solubility is talking about how much solute I can get to dissolve in a solvent. Not how fast I can get it to dissolve, but how much will dissolve. So what we're talking about in this picture is we've got 3 containers, and they each have different amounts of sugar in them. The solubility of sugar is 204 grams per 100 milliliters of water. So this is at room temperature. So we can dissolve 204 grams, and that's the maximum amount that will dissolve. If you put in 205 grams, it can only dissolve 204. One's going to be left over and sink to the bottom. So this picture's a little tricky, only because you'll notice that it's not in 100 milliliters of water, it's in 50 milliliters of water. So you really have to pay attention to how much solvent they give you on the homework sheet, because it's not always out of 100. Most of the time it is. Most of the graphs you're going to see are out of 100, but sometimes they do some pretty weird stuff. So in this beaker, you'll see that there's 80 grams. Well, that's a lot less than 204. And so if this was 100 milliliters of water, we double that. So that's 160 grams for 100 milliliters of water. So we have a name for that, and we call that unsaturated. And then in this one, it's got 102 grams for every 50 mils. If we doubled that, that's 204 grams. So in this one, this is the maximum amount that we can put in and get it to all dissolve. That's saturated. And then in this one, okay, in this one, we put too much. We put 120 in 50 mils. So if we doubled that, that's 240. And so since 204 is the max, that means there's 36 grams that sinks to the bottom. So something is considered unsaturated. The word unsaturated to me means unfilled. So if it's unfilled, that means it can still hold more than what is currently in there. And so since it had less than its maximum, we call him unsaturated. When he has dissolved his maximum amount, we call that solution a saturated solution. It's filled. A sponge, when it's full of water, it's called saturated. And then the one is a little weird. I don't want you to get misled here, so pay attention. Supersaturated does not mean that I put too much in and some of it sunk. Supersaturated really means that I've gotten the solution to dissolve all of that. So that means this wouldn't be showing down at the bottom at all. So how in the world do you get something to dissolve more than it should? I would add this, and I would say because it was heated. So a lot of you like Chicken Express sweet tea. Nasty. I don't know why you like it, but you do. Chicken Express is really good at this. They want that tea to be so super sweet. And so when they make that tea, you're going to heat that tea up and make it really hot. And you're going to dissolve all that extra sugar. And then you're going to cool it back down to room temperature, or even colder if you put it over ice. And so we've kind of like tricked the solution to hold more than it should. So supersaturated, it's containing more solute than it should because we heated it up and then we cooled it back down. Now the weirdest part about this is that we can get those crystals that shouldn't be dissolved to come back out of the solution. Remember last week we talked about that when something dissolves, it's really just being hidden by the water molecules that surround the ions or the molecules that they're dissolving. And so they're still in there. But we know that they shouldn't be in there because at that temperature, it can only hold a certain amount. So watch this cool little video, and it's going to show you what happens when the solution figures out that it's supersaturated. It kind of freaks out, and it says, wait, I shouldn't be dissolving all of this, and it spits it back at you. It's really interesting to watch.
So we have a supersaturated solution. There's more that can normally be dissolved in there at room temperature. It's very unstable. One way to get it to come out of a supersaturated state is just by vibrating it. Sometimes when I sit on the desk, that's enough for it to come out of a supersaturated state. Or the coolest way is by using seed crystal. So seed crystals of sodium acetate will allow those ions that are in a supersaturated state to recognize the crystal structure of these sodium acetate crystals, and they'll be attracted to it. And as that seed crystal gets bigger, more will be attracted to it. And as that gets bigger, more will be attracted to it, and exponentially gets larger until it goes back to its saturated state. Let me show you. Just a couple of crystals. And if you zoom in, you might be able to see that sort of suspended in the middle of the solution now. And then those at the front of the room in just a moment, we'll be able to see that begin to grow. Can you all see that? So now, when that crystal finishes growing, what type of solution will I have again? So it's gone from supersaturated back to its... I'll pick this up and just hold it at an angle for you. And you guys can see that there's much of a solution here. This part of it's completely saturated, isn't it? And you can see the large crystals that have been made at the bottom. It looks almost like a solid chunk of ice, doesn't it? Now also, when you feel the bottom of this one, it feels quite warm. And we'll talk about why that is in just a second.
So we know how much solute can dissolve in different solvents at different temperatures. So we can actually graph that in what we call a solubility curve. And so it's basically a bunch of different chemicals that we are trying to dissolve in water. Let me show you some pretty important stuff that you're going to need to know for doing the homework. Check out this y-axis. This y-axis is your solubility. Sometimes they label it solubility, sometimes they label it the grams of solute that can dissolve, but the other important part about that right here is, see where it says 100 grams of water? So if the problem on the homework is not at 100 grams of water, you have to come up with the ratio and figure out, oh, well, if I only had 50 grams of water, I have to cut these values in half. If I had 200 grams of water, I need to take these values and double them. And so a couple of other things on that y-axis, check out what's in this box. You might see any of these as your units over on that y-axis because these are all the same. Since the density of water is 100 milliliters is exactly the same as 100 centimeters cubed, which is exactly the same as 100 grams of water. Just always pay attention and make sure that you know how much water you're talking about. Most of the time they'll give you 100, but not always. The x-axis is temperature in Celsius. We're not doing any gas law problems, so we don't have to convert anything to Kelvin or anything like that. So the way this works, if I wanted to look at sodium nitrate, that's right here. And if I said how much sodium nitrate can dissolve at 30 degrees, you'd start here at 30 degrees and you'd go up until you hit the line and you'd go over and you would say 94 grams. So at 30 degrees, which is a little warmer than room temperature, 100 grams of water can dissolve 94 grams of sodium acetate. So this line that sodium acetate is on here, this part of the line represents saturated. So that's the maximum amount. And notice, as the temperatures get warmer, it can dissolve more and more and more. As the temperatures get colder, it can dissolve less and less and less. So you'll notice that our lines all kind of sort of go up. We've got one, which is salt right here, which barely goes up at all. What does that tell you about salt? It doesn't matter if the water's hot or cold. there's just only so much salt that can dissolve in that water. So heating up your water doesn't actually help your salt dissolve better. Just got an email. And so you'll also notice, which is kind of random, we've got this guy here. Why would his line go down? And it's because he is not a solid. Everybody else that's going up is a solid. But this guy is going down, which means as it gets hot, less and less and less dissolves. So this is actually a gas. So anytime you have something that's going down, that is considered a gas. So we've got saturated, that's on the line. Then let's talk about what happens below the line. That's pretty easy. So if we were talking about sodium acetate again, I'm sorry, not sodium acetate, sodium nitrate, then if we picked a point right here maybe, at 30 degrees, if there's 80 grams that dissolved, would we call that solution saturated, unsaturated, or supersaturated? Well, let's think about it. I've only got 80 in there. I can dissolve 94, but I've only currently got 80 grams in. So because I can still dissolve more, we are going to call that solution unsaturated. So if it's under the line, pretty easy to remember, unsaturated. On the line is saturated. Now check out above the line. I know what you're thinking. If we had a point up here, you're just going to say, oh, it's supersaturated. No, not always. Sometimes, if the point is above the line and they tell you that it's all dissolved, then yes, it's supersaturated. But this could also be saturated above the line. Think about it. I put 130 grams, because I go over here and find the 130. I put 130 grams into my 100 grams of water at 30 degrees. Now, it doesn't all necessarily have to dissolve. We already know that it can dissolve 94 grams. And so if I put in 130 and only 94 dissolves, what's going to happen? Well, 36 grams is going to sink to the bottom of the container. So at that point, you have a saturated solution. It dissolved the 94, and the rest just sank and sat at the bottom, so nothing exciting is actually happening. So now you're going to try. You should be pretty successful, and I'll see you tomorrow.